So please.
Yes, good morning, everybody. Yeah, I will not be touching the technical parts. I will be touching the practical side. I will be reflecting our experience as a contractor who was involved in the design, the research, and the operation maintenance, and the construction. I think because one time we had some discussions about the differences between centralized and decentralized. I thought we just go over this very quickly because that will lead us to the problem when we plan for decentralized wastewater treatment. You know, in Jordan, anything except for Khirbet al-Samra, centralized plant will be 2,000 to 5,000 meter cube per day. Well, for Egypt, this is maybe a decentralized plant.
Yeah, of course.
In Jordan, a decentralized plant we are talking about 20 to 500 meter cube per day and maybe up to 1,000 cubic meter per day. And then anything smaller than 20, that is what we call an on-site solution. The difference really between, again, centralized and decentralized is the site location. With the centralized plant, they are usually located away from the accommodation or away from the city. So they are 3 to 5 kilometers away from the city, and that is the law in Jordan. They are not only put there by accident, but it's a law in Jordan. While in decentralized plants, these are normally constructed next to the living accommodation. And sometimes they are actually not only next to the living accommodation, but they are even in the basement of a building. That leads us to the approach. Now, the difference in the approach, how, what happened? Okay. That leads us to the approach, how we plan for the decentralized and the centralized. With the centralized, because it's a huge project, it's a big project, then you have different entities involved. One company is doing feasibility, one company is doing case study, another company doing the design, another company is doing the construction, another company doing the operation maintenance. While in decentralized, these are shrinking, so a multitask company is now required. The whole work can be done by a single company, but at the most it's done by 2 or 3 companies. Also the ownership. The centralized plants are normally owned by the government, while decentralized plants, sometimes they are owned by the private sector. The management of the operation maintenance, again, that is slightly different between centralized and decentralized because, again, on centralized plants, they are big. Then you need a lot of experts there, which you cannot afford to have on a decentralized plant. Then, otherwise, the operation maintenance cost will be very high. Now, when we go to the planning for decentralized wastewater treatment plant, just like any other project, you have to go for the case study, feasibility study, EIA study, design site selection, technology selection, then putting the terms of reference, then do the construction and tendering, and after the project is finished, then you have to think about the operation maintenance. But in decentralized plants, I think operation maintenance, we really have to look into while we are doing the TOR, while we are doing the study itself, because that has to be really made simply as simple as possible. As I said, we cannot afford having experts operating and taking care of decentralized wastewater treatment plant. Otherwise, it will be very costly. In the case study, it's a little bit different when we talk about decentralized and centralized. In decentralized, on centralized, we normally have an average figure of a huge community. Now, in decentralized, we are talking about a particular community, and each community has a different characters. Some communities, they are using more water, some communities are using less water. The pollution is more in one community than the other community. So the data collection from each site where we have to implement a decentralized plant is not the same. And we have to go and collect the correct data in order to start our planning. Social acceptance and local culture, that was also an issue which we have faced during our work, and that was sometimes quite serious and pulled us away from various projects. But I think we are trained now to do that, and awareness is a little bit getting a little bit better. In many cases, what I have noted that people, they plan for their centralized plant or decentralized plant for only the treatment site. They did not go for the reuse. And in my opinion, you always have to think with on the two items together, treatment and reuse. That is really the optimum approach. Feasibility study, yes, it's a small plant, and maybe it's not, some people may think it's not very important, but it's interesting. I mean, as we are engineers, we really have to calculate the economical feasibility study, and that's not very difficult. But even though based on experience, we always see that it is 50% cheaper to do, to have or to own and operate decentralized treatment plant rather than spending the money on hauling away the sewer. Environmental impact assessment, that's another story, but that's a long story. Really, I'm not going to tackle much, but it is a point there with the decentralized treatment plants. There is a very high requirement here in Jordan, which was set for the centralized plants. Now for decentralized plants, I think this has now been tackled through the project from Smart and Swim, and it's becoming a little bit more lenient and more easier. Technology selection and site selection. These two things they really go together. Technology selection, in treatment plants, you have different technologies like standard aeration, SBR, MBR, MBBR, RBC, submerged fixed bed, wetland, etc. But that really depends on each site. According to the site conditions and the application, you really have to select the correct technology. What I want to say, I have seen consultants, they do the study, they write the study, they explain the advantages and disadvantages on each technology, and they tell you this is bad, and then they go and choose it. And I have seen that. So the idea is correct. You have to make the comparison. What is best for this site, and go and take the technology which is best for this particular site. Design parameters. This is very important thing, and this is where we have had a lot of conflict and a lot of discussions with the people concerned setting up the design parameters. I see some people, they smiled. Okay, the design parameter of the influent and the effluent. The influent, I just put some rough calculation there. If we are designing, let's say, 100 PE, took just a round number, 100 PE on one site, they are maybe using 80 liter per person, and if we assume 65 milligram BOD per person per day, then my parameters are 8 cubic meter per day with 6.5 kilogram BOD per day. And that's, and I insist that the TOR should say 6.5 kilogram BOD per day. Not enough to say the concentration is 812, and that is calculated. While if we are talking about 100 PE with people who are using 120 liter per day per person, 65 milligram per person per day, then the flow is 12 meter cube per day. The load in kilogram is the same, still 6.5 kilogram, but the concentration is 540. So when we set the parameters, we have to know where to go. We have to collect the correct figures from the site in order to set the correct parameters. Here we have a little bit more hydraulic load, but in both cases we have exactly the same biological load. And that's what counts. That's where my reactor will have to work, regardless of the technology. I will have to work with 6.5 kilogram BOD per day. Okay? In many cases, the specs will say only the concentration, and they go and say 1,000, you know, in many specs they did like this. 800 milligram per liter concentration and the flow of 12 meter cube per day for 100 PE. It doesn't fit. You know, it is calculated, so it has to be, if it's either this or that. Yeah, it's plant design, layout, and sizing. This is something normal which we have to do in every project. It's not moving. Touchpad is not moving. Okay. When we go also to the equipment selection, that also makes a big difference. This is an air blower, side channel air blower. Then we have a positive displacement air blower. That's again an air blower. And then we have a positive displacement air blower with a sound enclosure. The difference, they are all blowers, but each one has a different specifications. When we compare the specifications to the price, I can tell you this blower will cost 3 times as much as this blower. So if we put in the specifications only I need a blower, that will not be enough, because somebody will offer me this, the other guy will offer me this. And he will be crazy to offer you this. Normally they should offer you this one. But whoever put the specifications, he has to know and specify what kind of, to be more particular on the specifications. Again, I'm taking the blower actually as only one example. Okay, so I have another slide on the blower. Okay, this is the selection table for the blower. So you can see the same blower, the same size, can give me from 83 cubic meter per hour up to 302 cubic meter per hour. It depends on what speed I'm going to run. Am I going to run at 2,000 RPM, or I'm going to run at 5,000 RPM? The difference is very small. The power consumption or the motor required is little. Here it's 1.5, here it's 5.5, and that corresponds to a small part of the cost. But the blower itself is still the same blower. And I can use, that means I can use this same blower for 3 plants, you know, or if I need a blower of to give me 300 cubic meter per day with low speed, then I need then I need 3 blowers, but I still can use 1 blower. So that's important, again, at what speed I'm going to run. In the specification, it has to be specific at what speed I have to run. Otherwise, people will tend and will offer you the highest speed. With the highest speed, then you will get, it's more heating, and then the lifetime is reduced of the equipment. Preparing, then we go to the second step. We have to prepare the TOR. In the TOR, again, my recommendation is always to be a little bit more specific. Keep it flexible, but a little bit more specific. We have specified the tank sizes, the specifications of the tank, of the concrete, of the sealing, of the protection, if you need epoxy protection, etc. All these details, they are money, and you really have to specify it. Then we have to talk about the inner and outer parts, whether they are stainless steel, galvanized, or epoxy coated, or painted. That also makes a big variation. We have to list the equipment as, as I said before, put the right specifications, be more specific on the specifications. And then, in many cases, many of the specifications we have seen, they included the spare parts. The spare parts are not put into the BOQ. They are not inserted in the BOQ. And then they are forgotten. It's always good to put that the BOQ will contain a summary of my specifications. Then you don't miss items, expensive items like spare parts. Then we go for tendering. We have seen tenders for 100 and 200 meter cube per day with a ton of tender documents, which is not practical.
Could you come to the conclusion, please? Because
Yeah,
time is short.
I will, okay. And vice versa, we have seen tenders where they have a lot of specifications regarding concrete, sewer lines, etc., but only 1 line or 2 lines or 1 paragraph for the heart of the project, which is the decentralized wastewater treatment plant. So the optimum, I think, that we have to consider 30 pages of general conditions, 30 pages of technical specifications, and 10 pages of a BOQ. Maybe it's good also that we consider a lump sum price for such projects, because then you have to make, or sometimes on items, because you have to make sure that tenderers will include all the accessories within their prices. That's very important, because we are talking about system. You know, with the system, sometimes you cannot specify each bolt. So it's better always to have a lump sum price that then people will include the whole item in their price. A unique point system for evaluation will be also a benefit during tendering. Tender evaluation, in many cases, tenders are evaluated by normal engineers who really don't know the systems. And that is really a problem. I mean, you really need qualified engineers to evaluate wastewater treatment offers. Then we go for construction and commissioning, operation and maintenance. Operation and maintenance, I only want to speak about small thing regarding the cluster solution to optimize the cost of operation and maintenance. It's always good to have a cluster solution where you have like 1 plant here, 1 plant here, 1 plant here, 1 plant here, and then you have 1 operator to operate 4 plants, not only a single plant. Okay, my friend Dr. Mayang explained about the National Committee. They have contributed, they are already, they have written some white paper, and which will contribute towards what I am just discussing now. My recommendation really, I will go very quickly to the last line, capacity building. We need really some capacity building for people who will put the TORs, people who are putting the specifications, and people who will evaluate the tenders. Thank you very much.
Thank you, Dr. Nabil, for your presentation that focused on the comparison between centralized and decentralized system, and also for the project implementation process, and finally to the strong recommendation concerning the capacity development needed for this type of system. We'll move to the third presentation with Engineer Thomas Hester. Thomas is a civil construction engineer, and his main area of experience focuses on the prefabricated small-scale wastewater treatment plant, which is very important actually for rural sanitation in Egypt. As you may know, that we have more than 4,000 villages, at least 20% from these villages fallen within the small-scale wastewater treatment plant, which needs prefabricated units actually. Thomas is a member also of German GIN standard committee of water engineer. He is going to speak and to present to us today about decentralized wastewater treatment and reuse in area experience with a small and small scale SCBR treatment plant in Jordan. So please.
To finish escape and then okay. Okay. Yeah. Good morning, ladies and gentlemen. I have the advantage that already a lot of things have been presented by Dr. Myong Lee and by Engineer Nabil Wakile, so I can perhaps keep it short with my first parts of the presentation, dear Chairman. Yes, I want to bring to you the content first of all, and I keep it really very short, about the IWRM Smart project. I will tell you a little bit about the demonstration and testing site at Fuhais, especially under the aspect of SBR systems. I will give you some explanations concerning the SBR proceeding, SBR and proceeding for arid areas, and the required performances for water reuse irrigation in Jordan. And at the end, I will present to you some systems which have already been installed here in Jordan. I think very quickly I try to explain a little bit the abbreviations which are used very often here. So I think I don't have to read it through because they have already been presented by Dr. Myong. Here is an overview about the demonstration site at Fuhais. I want to focus on the red part here, which you see. These are 3 SBR systems which have been installed at the Fuhais site. You see here a part of this demonstration site, and here are the 3 plants I'm talking about. These are 3 different SBR systems. One traditional standard SBR system, the same system followed by a UV light treatment, and also a CBR system. This is a special SBR system. To say it in advance, the CBR system has good result, but it's not very good for the applications because it's a little bit too complicated, and so I can relate on what Engineer Nabil Wakile said. It is very important not only to have a good technology, it is important to have technologies which are easy to maintain, easy to service, and you don't need really high technology results. You have to have good results, and this in the long term for that. These three systems have been selected. Dr. Myong already told us they have been pre-selected, some German technologies, and we have pre-selected this also under the aspect of the Jordanian standards for the reuse. That means to fulfill standard category A or standard category B. So the system with the UV light treatment has been foreseen for fulfilling category A, and the other ones for fulfilling the category B. I will show you a slide a little bit later where the standards will be shown. The SBR process which had been used here is a SBR process which lasts at least about 8 hours. That means the water will be treated in 3 cycles a day. The difference between the traditional systems and an SBR system is that all parts of the treatment will run one after another. So you have the different steps of treatment are separated by time and not separated by the location in different tanks. That has also the big advantage that you need less footprint for such a system. You see here, it is a little bit a general system, a small tank. On the left side, you have the primary treatment, which also acts as a buffer. That means a buffer to avoid peaks. That means, I come back to engineer Nabil Wakile, peaks in the aspect of the organic load, but also peaks on the hydraulic load. That this can be a little bit buffered. So now look at the clock. If we would start at noon or at midnight, at 12 o'clock, you see a brown phase. That is a so-called feeding phase. That means the water from the primary treatment, where it is pre-treated physically, will be led to the biological reactor. And with the system which is shown here, you see this happens 3 times, at the beginning, 2 hours later, and again, other 2 hours later. In the green zone, there the biological treatment will take place. This is an aeration, but not a permanent aeration. It's an intermittent aeration. That means we have certain times of aeration and arrest, aeration and arrest. This also can be adapted to the targets you have concerning your treatment targets. That means, for example, if you need a reduction of nitrogen, then you will also have the possibility to fill in anoxic phases and oxic phases. So what Engineer Nabil told us, it is important to know what is the target, what really is wanted for such a system. During these 6 hours, the treatment takes place, and after these 6 hours, we